Alright class, this is a reminder about our notes for Lesson 3-3 on Deductive Reasoning. We started off, we were concerned whether statements were true or false. If you take a minute to try these out, you will find that we agreed on the first statement being a true statement, the second statement being false, and the third statement being false. These were rather easy logical statements. It was easy to tell whether they were true or false because you know how to make arguments. What we're focusing on today was two rules, two ideas in arguments that you already use, you just don't know names for them. We were going to be talking about laws of detachment and law of syllogism. And to get started with it, we needed to know what deductive reasoning was and what inductive reasoning was. We started identifying inductive and deductive reasoning by just looking at our situation here. If a student is late returning a library book, then he will be charged a $2 late fee. Chang returned a library book late, so we concluded that he will be charged a $2 late fee. We said Chang was basing his reasoning on a rule. We were interested in how Chang was making this conclusion. We concluded Chang based his reasoning on a rule. Tamika had a similar sort of thing. Every time Tamika wore her favorite jersey to a football game, her school's team won the game. Tamika is wearing her favorite jersey to the football game tonight, so she concluded that her school's team will win the game. Tamika concluded her team will win. She based her reasoning on a pattern. These are two different ways of reasoning. Reasoning based on a rule and reasoning based on a pattern. Reasoning based on a rule is deductive reasoning. Tamika's basing her reasoning on a pattern is inductive reasoning. You can remember the difference. Detectives are deductive. They follow some rules to come to their conclusions. We then took a look at the first sentence there. We were talking about that first sentence. If a student is late returning a library book, then he'll be charged a $2 late fee. We broke that up into two parts. We've seen these sort of parts before. We called them our hypothesis and our conclusion. P and Q. Q is conclusion. P is the hypothesis. Our hypothesis led to our conclusion. That was a true statement. Now, Chang returning a library book late, that idea matched our hypothesis. This idea here sort of matches our hypothesis. So his conclusion would match his conclusion as well. That's what our law of detachment says. If we have some reasoning, if P implies Q, or if P leads to Q, is a valid rule that you know, and you have something that matches the hypothesis. Chang returning a library book matches the hypothesis, then we can conclude he'll be charged a $2 late fee. We can conclude that Q is also true. That's what our law of detachment is. We gave an example of if a car is out of gas, then it won't start. We have a hypothesis, car is out of gas, it won't start is our conclusion. It's a valid argument. It makes sense. If we then had a statement that is matching our hypothesis, if we said something specific like Kyle's car is out of gas, we can then conclude Kyle's car out of gas matches the hypothesis, a car is out of gas. We can conclude Kyle's car won't start. That's all our law of detachment was. We're going to see it quickly 2 more times here. We want to determine whether the conclusion made is valid or true based on the given information. We'll either write valid or invalid. To go on a field trip, a student must turn in a permission slip. Mariana turned in a permission slip. Can we conclude that Mariana can go on the field trip? Well, let's identify the hypothesis and conclusion first. A student must turn in a permission slip? That's a hypothesis. That has to happen. The student turns in a permission slip. Our conclusion is they get to go on the field trip. Conclusion is a student goes on the field trip. Our hypothesis leads to our conclusion. The student turns in permission slip leads to this idea that a student goes on the field trip. Mariana turning in her permission slip, which thing does it match? Well, it matches the hypothesis idea. Mariana turned in her slip. It's the same idea. So we can go in the same conclusion. Mariana goes on the trip. That's a reasonable thing to conclude. So this would be a valid conclusion. It would be true. We have another example. If a figure is a square, then it is a polygon. Figure A is a polygon. Conclusion that figure A must be a square. Let's start by, again, identifying the hypothesis and conclusion. Our hypothesis is a figure is a square. Its conclusion, the figure is a polygon. Let's write those down. A figure is a square. We can conclude a figure is a polygon. Now, this is a valid argument. If something's a square, then it's a polygon. A polygon is just a type. A square is a type of polygon. This is a valid argument. The logic is flowing in one direction. It makes sense. It works. Figure A is a polygon. That idea, that statement, that doesn't match the hypothesis. That instead matches the conclusion. So we'll write that down here. Figure A is a polygon. Does this mean we get to go backwards and conclude figure A is a square? Do we get to conclude this? The answer is no, we don't get to conclude that. The logic flows in one direction, from hypothesis to conclusion. We don't get to go the other way. We can't conclude a hypothesis given a conclusion. You guys gave some counterexamples. You guys were able to tell me a rectangle is what our polygon could be. Our polygon could be a rectangle, it could be a pentagon. It doesn't have to be a square. Our counterexample could be a rectangle, could be our choice. Figure A could have been a rectangle. It didn't have to be a square. We'll zoom out a little bit. All right. Last thing we wanted to be concerned with was law of syllogism. It's another argument you've seen plenty of times. You've definitely used it plenty of times. You just never had a name for it. No one really ever has names for this. We wanted to draw a valid conclusion, something that would make sense and be true from these two given statements. If you do not get enough sleep, then you'll be tired. If you're tired, you'll not do well in your test. I challenge you guys to just write that as one sentence. The easy sentence to write is this. If you do not get enough sleep, then you won't do well in your test. The combining ideas were this. Notice that then you'll be tired was the end of one statement and the beginning of the other. Since it was the conclusion of one statement and the hypothesis of the other, we get to just sort of cut it out. If we were to diagram these two sentences, we might say, if you do not get enough sleep is our P, our then you'll be tired is Q, if you are tired is Q, and you will not do well on your test is R. P leads to Q, Q leads to R, so we get to shortcut it and say P leads to R. That's what our law of syllogism is saying. If P to Q is valid, true. If that's a true argument, and Q implies R is a valid or true argument, then P implies R is also a valid argument. With this, you had 6 problems. This was our notes for this page. As a reminder, you had these couple problems on the back. You had to identify whether things were inductive or deductive for 1 and 2. You had to try and construct an argument. You had to figure out if you could draw a valid conclusion or not from the given statements. If you could, you needed to identify if it was law of detachment or law of syllogism. If you couldn't conclude anything, you would just say no valid conclusion. That was our notes.